Our next presentation from Giacomo Inches at Fincons describes work being done in the EU's Content for All project to make signing more widely available by automating most of the process. Giacomo.
Hello, my name is Giacomo Inches, and I'm the coordinator of the Content for All project, and I'm very happy to give you an overview of the project's technology within the framework of this DTG webinar on accessible technologies for broadcasting. The Content for All project is a co-funded project by the European Commission, which started in September 2017 and will be completed by the end of 2020. And it's directed under the Media Convergence and Social Media Unit of the European Commission. The main aim of the project is to make more broadcast content accessible to the deaf community. And for doing that, we divided the project into two main phases. In the first phase, we create a workflow for a remote sign interpretation, where a human signer is sitting in a remote studio, for example at home, and can interpret the content that is broadcasted, animating the 3D virtual human, which reproduces exactly his or her interpretation, and then to be distributed to all the viewers via the broadcaster content delivery network. In the second phase of the project, instead, we are trying to animate the virtual human automatically by analyzing the subtitles of the TV stream and then extracting the animation parameters corresponding to the text on the screen for the virtual human. The project is a collaborative one, so there are 6 partners involved. We are Fincons Group, and we are the coordinator of the project and the system integrator. Then together with us, we have 2 broadcasters, VRT, which is a public broadcasting company in Belgium with a Flemish language. And then we have Swisstext, which is the innovation arm of the Swiss public broadcaster. Together with us, we are also 2 research institutions, the Fraunhofer HHI, which is responsible for the virtual human creation, and the university in UK, the University of Surrey, which is responsible for the languages technologies. And last but not least, we have the HFC Human Factors Consult, a company based in Berlin, who is responsible for the user studies. And then we are very pleased to have the Swiss Federation of the Deaf in the advisory board to mentor and follow all the different project activities and make sure that we are compliant with the deaf community needs. What we are trying to do in the project is to allow broadcasters to create more signed content and thus to be compliant with the most recent legislation, for example, the UN Convention on the Rights of Persons with Disabilities of the European Accessibility Act. Another very important aspect of the project is to have broadcasters to reduce cost of interpretation. So as you may know very well, when you need to create some signed content, you need a sign language interpreter coming to your premise, complete the work, and then going back home. And the result is that maybe for producing a few hours of interpretation, you require a lot of employment by the user, so even several hours of employment. And in Content for All, we envision a solution which is based in a remote studio that can be placed anywhere, also at the interpreter home, and from there, the interpreter can simply provide the interpretation, and this interpretation is delivered to the end user, to the viewers, thanks to the virtual human, which is animated in a real time by extracting parameters from the video of the interpreters that are at home in their remote studio. And this is purely work, and the only overhead here is the creation of the 3D virtual human, which can be done only once and then can be reused for one interpreter or for multiple interpreters by the broadcasters. And this solution is helping in reducing the cost of interpretation because you reduce the overhead and give the possibility to the sign language interpreters to interpret even more content. One of the other advantages of having a virtual human reproducing a sign interpreter is that the virtual human can be personalized in gender, physical appearance, clothes, branding, and it can be done at the 2 sides, so at the broadcaster side and the end user or viewer side. And the other advantage is that this concept of the virtual human interpreter animated by a remote studio can be employed in several domains, not just broadcasting, but potentially in all domains where sign language interpretation is needed. So the interpreter can work from a remote location and the audience can follow on a mobile device or TV, for example, for events, for classes, for governmental events, or for politicians or political events. As a matter of fact, the workflow we designed is generic enough to support all these domains, in particular the broadcasting one. So the workflow is composed by three main components that are able to deliver the signed content to the end users to be consumed, as I said, on the TV or browser. So the workflow starts from the remote studio where we have devices to capture the real human signer. At the moment, we are employing a SDI professional camera and a Microsoft Kinect to capture on-premise the signer. This data is then streamed to the central processing unit, which can be a single or a set of powerful servers, eventually also in the cloud, where we process the data and enhance and body modeling module according to different artificial intelligence algorithms to their parameters to animate the virtual human in the 3D model renderer module. This module generates a video stream which is mixed together with the original broadcasted stream to be distributed with the content delivery network to the end users. And this can be consumed with the HPP-TV application developed during the project, which also supports the standard HPP-TV 2.01. Now, I'll dive into the technologies for the virtual human animation. So we call it virtual human and we call it Realatar because it is aimed to be an avatar as close as possible to a real person. And in order to animate it, we decompose it into two different main parts, which are the face, the body, and the hands. For reproducing the face, we have two technologies available. One which simply projects the video of the real human on the 3D model head. So it looks the most realistic possible. And the other technology allows us to analyze the video of the face of the sign language interpreter and derive animation parameters, which are then used to animate the parametric 3D face on the 3D model. For the reproduction of the hands and body movements, we rely in the first place on the Microsoft Kinect for the body skeleton movements and on a deep learning algorithm for understanding from the video of the signer which signs he or she is doing. And besides that, we are investigating another technology which is instead purely video-based, and it's based on different deep learning algorithms. The first option is based on a combination of two sensors, which are the Microsoft Kinect and the SDI professional camera. With the Kinect, we extract the body skeleton of a person, while with the camera we process the video stream and crop the person's face into the 3D model and we crop the hands and then we process them with a deep learning algorithm which assign a hand sign category to each video frame containing a hand. And the drawback of this system is that the number of signs that we can recognize is finite, although we can introduce new categories if needed. And the other technology we are working on is purely video-based, and for this we don't need the Microsoft Kinect, but only the professional SDI camera. This is a two-step process. In the first step, we employed an algorithm for extracting the person's skeleton information for the body and for the hands from the video, employing the well-known open pose algorithm. Then, another deep learning algorithm called regression, we turn that 2D information into a two-dimensional parameters, which are able to animate the virtual human. In the following video, you can see an example of the two technologies. You can see the video of the human signer and then the virtual human or Realatar animated by the two different technologies. depth and regression. And you will notice the differences in the hands movement and in the body movements because of the nature of the two technologies.
Und in dieser Nacht klart es natürlich dann auch ab. Jetzt im Moment haben wir sogar knapp über 20 Grad. Es gibt eine relativ frische Nacht. Morgen am Morgen früh haben wir zum Beispiel im Raum Zürich noch gerade 9 Grad. Sonst so die Tiefstwerte um die 10, 11 Grad. Ein bisschen wärmer ist es in Genf. Oder natürlich im Tessin, Lugano hat um die 17 Grad.
What I have presented so far was dedicated to replicate the real person into a virtual one by replicating body, hands movement and facial expression. While in the second phase of the project, we focus on the automatic sign language production. The focus here is in understanding how far we can go with the current technologies of automatic language translation in producing sign language starting from text and for a small domain of discourse, which is subtitles in a weather forecast program. The system is working offline as opposed to the previous workflow, which is instead fully integrated into a broadcaster production workflow, and receives in input audio, video, and subtitles in German, because it's one of the languages of one of the two broadcasters in our project. And from the subtitles, we try to derive animation parameters for animating the virtual human, which might then complement the video with the signing information. We have obtained some preliminary results for animating skeleton of a body and hands based on the subtitles. And in this slide, you can see a qualitative comparison between the video of the real signer on the left and on the right, the body and skeleton derived from the real signer video. These parameters are extracted from the real signer with the open post-process regression algorithms presented before. With the red square in the central image, instead, you can see the skeleton for body hand generated automatically from the subtitles thanks to a deep learning algorithm. And this is only a visual comparison of qualitative and of quantitative differences between the automatic generated skeleton in the center and then parameters extracted from the video on the right side. You should imagine that the skeleton in the center has been generated by an algorithm that doesn't know anything about the video and only knows the relationship of the sign and gestures with the text. At the moment, we have some very encouraging results, and we are working on extending the skeleton for body and hands to include also the face and mouth movements. And later we will try to use all these parameters to render the signing with the Realatar instead of the skeleton or abstract stick model. While we are working on the automatic sign language generation, we are also working on optimizing the workflow and making it possible that it runs on a cloud so that it can be deployed practically anywhere in a very short time instead of moving equipment or hardware. And we are very keen in looking for collaboration in this. And this basically concludes my presentation and the overview of the Content for All project technologies. And we are very happy that these technologies lead us to receive the Innovation Technology Award presented by NAB that we should have received in April in Las Vegas, and we received 2 weeks ago during the NAB Express online event, but we are happy anyway. And we are really happy to have been invited here today at the DTG webinar and to have had the possibility of introducing you of some of the project technologies. And I'm here to take questions, and in the meantime, I hand it over to David.
Thank you, Giacomo. That's a very ambitious project with many elements that individually would be significant in themselves.